Alright, today's video is going to be on 5.1, our second day of graphing quadratic functions. We did this yesterday as well. Yesterday we focused our attention on two different equations. Our standard form, which is y equals x squared plus bx plus c, and vertex form, which is y equals a parentheses x minus h quantity squared plus k. And the nice thing about vertex form is when you look at it, you can actually tell what the vertex is. The vertex is at HK. And intercept form, which is new today, is y equals your a on the outside, x minus p, and x minus q. And when you look at the intercept form, what you're going to be able to see are the x-intercepts. Your x-intercepts are at p comma 0 and at q comma 0. Remember, anytime we have intercepts, we always put it in coordinate form. So those are the three equations that we're going to look at today. When we look at all three, we notice that all of them still have that a value. Your a value is still going to tell you the shape and the orientation of the graph. So if your a value is a 1 or a negative 1, so these first three we're going to be talking about the shape. If it's 1 or negative 1, then you are going to have a normal shaped graph. So it could be y equals a positive 1x squared plus 2, or it could be a negative x squared. It does not matter how many pieces are with it, just what matters is the fact that it's either a positive 1 or it's a negative 1. That 1a value is going to tell you a normal shape. If it's a big number, absolute value is greater than 1, then it's going to be narrow because it's growing at a faster rate. So we've got y equals, we could have 3x squared, or we could have y equals a negative 5x squared plus 2x plus 10. What matters is the fact that that number is a number that's greater than 1. And remember, we don't pay attention to the fact that it's negative because it's the absolute value of it. And last, if we have a fraction or decimal between 0 and 1, we're going at a slower rate, so we're going to have a y graph. So y equals 1/2 x squared plus 5, or we could have a negative 1/6 x squared. We're just looking at that number that's with the x squared. The next two are going to tell the orientation. If it is negative, then it's going to open down. And it doesn't matter, it could be a negative 1x squared, it could be a fraction, a negative 1/3 x squared, or it could be a large number, negative 100x squared. So just the fact if the a value is negative, it's going to open down always, and if it's positive, it's going to open up. So again, we could have a positive normal graph, we could have our fraction that's positive, or we could have a large number that is positive. Just the fact that it's positive is going to tell us which direction it opens. And positive is up. Okay, so what we're going to do is we're going to look at each of these graphs. When we look at the first one, y equals 2x squared minus 12x plus 19, we can tell that that's going to be in standard form. And when it's in standard form, the only thing that we can tell is shape and orientation from the equation. We see that our a value is 2. Since it's positive, it's going to open up. Since it's greater than 1, it's going to be narrow. Now, I can't tell anything else without going to my calculator. So you should be pressing pause now and getting your calculator out. Alright, so I have my calculator out. I've entered my equation into y1. And I'm going to go ahead and graph that to find my vertex. So when I hit graph, I see, as we expected, that the graph is going to be opening up, which means my vertex is the lowest point. So I go to second trace, and if I want the lowest point, my options are min or max. Lowest point is min, highest point is max. So we're going to go to number 3, and it tells us to go left bound. What it wants you to do is go left of the vertex. Here's my vertex. Right now my point is at 0, 19. And if you want to see your cursor on the screen, it'll tell you where it is, it'll tell you where it's moving if it's off the screen. So that's left of the vertex, enter, and it will ask you to go right bound. So I scroll right of where the vertex is, I hit enter again, and it wants you to guess. So go back towards the middle, and you can see the arrow is going right, left, and now we want to go towards the middle. And we've got 2.9 repeating, comma 1. Yours may say something different. Be smarter than the calculator. All those 9s really is going to be rounding to 3, comma 1. The equation of our axis of symmetry, remember, is that vertical line that's going to cut that parabola in half. So we've got x equals 1. Our y-intercepts, if we want our y-intercepts, that's when x is equal to 0. So to find that, we go to second trace. We want to find our value, and we want to find the value when x is 0. Hit enter, and we find that our y-intercept is at 0, 19. If we want our x-intercepts, that's when y is 0. And remember, that's why we put that y2 equals 0. So I can just find the intersection. So I go to second trace, number 5. First curve, enter. Second curve, enter. Find where they intersect. Oh, look, it says quit, sign, no change. So we get an error message. Go ahead and quit out of that. And hopefully you kind of see why, and you should have expected that. I want to know where my parabola crosses that x-axis, and it never actually crosses. So in this case, we don't have any x-intercepts. Notice that we don't have any grids like we did yesterday. We are going to sketch our graph. When you sketch your graph, you should still have important points. And we have a vertex at 3, 1. So I would say that would be around there. And I have the equation of the axis symmetry is that vertical line, what cuts it into. Oh, you guys should have been yelling. I was wrong. I was wrong. It's x equals whatever your x coordinate is. So that's actually x equals 3. Bet you feel better now. And our y-intercept is at 0, 19. So we're going to make that point right there, 0, 19. So we've changed our scale, and since we're sketching it, we don't have to worry about labeling our numbers. And we know that it's going to be opening up, and we don't have any x-intercepts. So that would be the sketch of our graph. And that's all for number 1. When we move over and we look at number 2, and we want to go back and enter our equation in, we don't even have to do that yet. We can just look at our a value for the orientation and shape. Our a is a negative 1/2. The negative tells me that it's going to go down. The 1/2 tells me that it's going to be wide. Now what's different about this equation is that this one is in vertex form. Since it's in vertex form, I can tell my vertex just from looking at the equation. I don't have to worry about that min-max. So my x coordinates at a negative 3, my y coordinates at a positive 5. Opposite of what you see inside, exactly what you see on the outside. And since we have our vertex, our axis of symmetry is going to cut that in half. Vertical line, x equals the x coordinate. Let's not make my mistake again. Fit the y coordinate, it's x equals a negative 3. So now the only thing that I need is going to my calculator for my x-intercepts and my y-intercepts. And I'm going to go ahead and let you do this on your own, so I want you to press pause now, enter your new equation in, find your new points, and then sketch your graph. Okay, so when we do our value, second trace number 1, we get that our y-intercept is at 0.5, which I've labeled here. Didn't label my other intercept. Then we go into and find the intersection between our horizontal line and our parabola, and we find our two x-intercepts. When we graph, we make sure that we label the vertex, any x and y-intercepts, and then we draw our axis of symmetry through our vertex. Our last graphing problem for right now is y equals x minus 2 times x minus 6, and this equation is in not vertex form, intercept form. And this is the new one for today. Our shape and orientation still on our a value. Since there's no number out front being multiplied, this a value is 1. Therefore, our orientation is positive, so it's going to go up. Our shape is the fact that it's normal. We don't know the vertex, we don't know this, we don't know. The only thing that we do know from this equation is that our x-intercepts. So our x-intercept is the opposite of what we see. So 2, 0 and 6, 0 are the two intercepts I would see on my graph. Now what I want you to do is go to your calculator again. The rest of the information, the vertex equation, the axis symmetry, and the y-intercepts, those are all review things, so I want you to be able to find those in your calculator. So again, press pause, enter your calculator, find your missing information, and graph. Alright, so our vertex we would find by finding our minimum, since it's opening up, and we get 4 comma negative 4, which means our axis symmetry is the vertical line through that at x equals 4, and when I calculate the value, I get 0, 12. Now the nice thing is, vertex form, intercept form, you can pull information out of the equation without going to the graph. That doesn't mean you have to. If you have your equation in vertex form, you can still do the min-max to double check and make sure that you got the vertex correct. You can find the intersection points for intercept form just to make sure that you have the correct intercepts. The different forms give you more information that you can see. That doesn't mean that you actually have to use it. You can go ahead and use your calculator and find everything the same way regardless of the form that it's in. Alright, so let's flip over to the back page. Alright, something else new for today is writing the equation in standard form, and we know what standard form looks like, and this is actually easier than you may think. In order to get to standard form, you just have to multiply out your pieces by order of operation. So the first thing I see here is that I'm squaring that quantity. So I've got 7 times, when I square x minus 2, you've got a FOIL, and you get x squared minus 4x plus 4 plus 1. The next thing in order of operations is to distribute that 7. So I've got 7x squared minus 28x plus 28, and then we have that plus 1 over there. So our equation standard form is y equals 7x squared minus 28x plus 29. So getting the standard form is just foiling everything out, but making sure that you're following the order of operations. So when we look at number 5, what I'm going to do, which I find easier, is to FOIL out those pieces first. So I've got a negative 3. That becomes x squared plus 2x minus 4x minus 8. So that's a negative 3 x squared minus 2x minus 8. And then I distribute that negative 3 throughout. So a negative 3x squared, a positive 6x, and a positive 24. And that's as easy it is to go from vertex form to standard form or from intercept form to standard form. Know the difference between your forms. And actually, that's the next thing that we are going to do. What I want you to do, kind of a test or quiz for today, is 6, 7, and 8. I'm giving you several different equations in several different forms, and what I want you to do is tell me what form it is and then tell me the information that I'm requesting from you. So press pause and go ahead and see if you can fill this out. Alright, go ahead and check all of your information. First one, vertex form, and because a is greater than 1, it's narrow, and you can grab the vertex directly from the equation. For the second one, it's an intercept form. Since a is positive, it's going up, and from the equation you can find those intercepts of 4, 0 and negative 12, 0. And last, it's in standard form. A is negative, so it's going to go down. We plug in 0 for x, and we find our y-intercept at 0, negative 2. Last problem, our application problem, and we've got a jumping mouse, and it has long distances for such a small size, and we've got an equation that's going to model its jump. X and y are measured in feet. How far can the woodland jumping mouse hop? How high can it hop? So your first order of business is to graph this equation. So what I want you to do is graph your parabola, find your vertex, and find your x-intercepts. Alright, so these problems are very, very important. You're going to see them on quizzes and tests. If we want to find out how far, we are looking at the horizontal change, which is 6 feet from 0 to 6. That is our change in our x-coordinates. If we want to find out how high up it is, then we're looking at the vertical change, and it went up a total of 2 feet. So just remember that x is representing the horizontal change, that's how far, and y is representing your vertical change, of which is how high. So make sure that when you look at your vertex, you're looking at the y coordinate.